Learned about choosing DC circuit breakers for my solar power systems over the years. Make sure you choose the correct type of circuit breaker for each use case, for example, PV solar feed, charge controller, inverter. Making the effort to get these details right and understand them is time well spent. There are so many DC 12 and 24 volt and solar PV circuit breaker options on the market, it can be hard to distinguish which ones work well and which ones don't. Reading honest reviews and performing a bit of research can save you a lot of trouble in the future. Watch out for dishonest sellers listing AC circuit breakers as DC PV solar rated. Use an ohmmeter to check new and existing circuit breakers for high resistance. This is a good idea. There should be very little resistance across the breaker, otherwise the breaker is suspect. If you are concerned about the resistance of the protective device and its efficiency, consider the following. The hotter a circuit breaker gets, generally, the greater its potential resistance and so the lower its efficiency. Believe it or not, a circuit breaker should be kept as cool as possible. Sometimes it's better to use an appropriate fuse, such as an A&L fuse, instead of a circuit breaker, as they generally have less resistance. And they too should be kept as cool as possible for the same reasons as circuit breakers. The reason is, depending on its design, if the fuse or circuit breaker is in an unusually hot environment, it may not perform as intended and may trip at a lower rating than it's supposed to. Quality circuit breakers usually have detailed specifications listed, and you should read them before buying. Avoid cheap circuit breakers that make false claims and or don't have proper specifications listed. A circuit breaker can't protect your investment of wiring and equipment if it doesn't work as expected. Assumptions can be deadly. It's important to do the research and ensure you have the right circuit breaker for the job and that it will really protect the system if there is a fault. It is important to pick a breaker with the right amperage rating for the application. Too low and the breaker will activate when there is a surge draw under normal operating conditions. For example, when an inverter starts up an air conditioner. Too high and it won't activate when there is a short circuit or a fault, leading to damage and possibly a fire. It's a good idea to learn to read and understand the labels on the front of the circuit breaker. For example, being able to tell the difference between AC and DC markings. On the left we have a symbol of a straight line over a dashed line, the symbol for DC or direct current. In this case the breaker is rated up to 500 volts DC, but I would not operate this breaker at its maximum rating. Furthermore, this rating is only at double pole, meaning each side of the breaker can handle 250 volts, so this 500 volt rating only applies when the circuit breaker is breaking both the positive and negative side of the feed. On the right we have the symbol that looks like a wavy line, the symbol for AC or alternating current. This is an AC breaker and not suitable for DC. This type of circuit breaker is actually called a mini circuit breaker or MCB, but there are a lot of classes and variations of each type, so it's important to pay attention to the details. For example, here we see this circuit breaker is rated for fast trip, meaning it's sensitive to overcurrent and easily trips. I prefer this type, but sometimes you would want a brief delay. This circuit breaker is rated at 15 amps, but sometimes that's not the whole story. Again, it's important to read the specifications and choose the right breaker for the job, because there are different versions which behave differently by design. Some circuit breakers are polarized, meaning they have a positive and negative polarity. Be sure to check the markings and specifications to ensure the breaker works correctly. Warning: if the DC circuit breaker is polarized and you install it incorrectly, it will lose its ability to protect the circuit and break arcs. It can be rather confusing to understand, but think of it this way: the polarized circuit breaker must interrupt the DC arc on disconnect or trip, and in order to do that, the voltage must be flowing in the correct direction. Markings on breakers can be confusing and vary amongst manufacturers. If you see positive and negative markings on the breaker, slow down and take the time to examine the specifications and installation instructions. Otherwise, this type of circuit breaker can be dangerous and won't protect your installation. When installing a circuit breaker, make sure and torque the terminals properly. Thermal expansion and contraction makes the wires want to move. The breaker will naturally warm up and cool down over the course of normal use. This can cause loose wires, which can lead to arcing, heat, and fire. Wires should also be clamped down near the breaker so they don't move at all. Stay away from the cheapest circuit breakers if you really want to protect your system. Don't cheap out. Saving $10 on a circuit breaker is not worth causing a fire or burning out wires and equipment. Consider testing a circuit breaker if you're not sure it will work, but only if you have the ability to do the test safely. Double pole DC circuit breakers can switch both the positive and negative side of the PV feed simultaneously. Circuit breakers are riveted together at the factory and thus cannot be serviced. Genuine high-quality DC circuit breakers are so complex inside, reassembling them would be pointless and educational only. I hope this video helps you out. Thanks for watching, and I'll see you later.